Hi guys, I'm back with my lectures. So today's lecture is a continuation of our previous lecture on solution and concentration, calculating solution concentration by what? By titration. So we just want to solve more advanced questions, more, complicated questions, a little bit complicated, but I just want to assure you this is as simple as ABC. All we just need to do is to understand the questions very, very well and make sure we write the equation and balance the equation properly. So once all those things are done, I think we'll be able to get the right solution. Okay, now 0.02 mole of aluminum is bound in oxygen, and the product is reacted with 2.00 mole per dm cube hydrochloric acid. You are now asked, what is the minimum volume of acid? What minimum volume of acid will be required for complete reaction? So the first thing we need to do is to write down the equation and make sure that the equation is balanced because it's very, very important. So from the equation, aluminum, which is Al, solid, reacts with hydrochloric acid, no, reacts with oxygen, is born in oxygen, gas, and the product will be what? Aluminum oxide, Al2O3. Solid. So what you need to check here, this is the equation, so we need to balance the equation. So let's look, aluminum is 1 here, aluminum is 2 here, oxygen is 2 here, oxygen is 3. So if we put 2 here, aluminum will be 4, and oxygen will put 4 here. Aluminum is 4 here, and aluminum is 4 here. Then we have to look at oxygen. Oxygen is 2 here, and oxygen is 6 here, 2 times 3 is 6, so we'll put 3 here. So oxygen is 6 here, oxygen is 6 here, aluminum is 4 here, aluminum is 4 here. So the equation is balanced. So the product is aluminum oxide, and the product is reacted with 2.00 mole per dm cube hydrochloric acid. So this is the product, which is aluminum oxide, Al2O3, which is the product. React with hydrochloric acid, which is HCl. So this is aqueous to give you AlCl3 plus what? Water. So this will get this liquid. So the next thing we have to do is to balance the equation. Make sure that the equation is balanced. So let's balance the equation. Aluminum is 2 here. So we'll put 2 here. Aluminum is balanced now. Then oxygen is 3 here. So we'll put 3 here. Oxygen is balanced. The hydrogen is 6 here. So we'll put what? 6 here. Okay. Hydrogen is balanced. Chlorine is 6 here. Chlorine is 6 here. So the equation is balanced. Now, when I asked to calculate the minimum volume of acid that will be required for complete reaction. So from the equation, 0.02 mole of aluminum is bound in oxygen, and the product reacted with 2.00 mole per dm cube hydrochloric acid. So, considering the first equation, 4 moles, when 4 mole of what? Aluminum is bound in oxygen, it produces what? 2 moles of what? Aluminum oxide, Al2O3, which is the product. Then 0.02 mole will generate what mole of what? Aluminum oxide. So you cross multiply. So now X now, which is the number of mole of aluminum oxide, will be equal to what? 0.02 multiplied by 2, then divide by what? 4. To now be equal to, let me use my calculator, 0.02 times 2. So you have 0. What? 0.01 mole. So we'll have 0.01 moles. Okay. Now, which is the product, which is aluminum oxide? So we'll have 0. What? 0.1 moles of what? Aluminum oxide, Al2O3. Now, when I go to the next equation, so I have to erase this so that now looking at the next equation, 1 mole of aluminum oxide reacts with 6 moles of hydrochloric acid. So if 1 mole of aluminum oxide reacts with 6 moles of hydrochloric acid, therefore 0.01 moles of aluminum oxide react with what moles of what? Hydrochloric acid, which will now be equal to, this 0.02 mole of aluminum is equivalent to 0.01 mole of what? Aluminum oxide. So we now cross multiply. So you now have 0.01 multiplied by 6 divided by what? 1. So you have 0. What? 0.06 moles of what? Hydrochloric acid. So we'll have what? 0.06 moles of what? Hydrochloric acid. Now, they now say what minimum volume of acid will be required for complete what? Reaction. So source of getting the number of mole of what? Of hydrochloric acid, that's 0.01 moles of aluminum oxide will react with, which is equivalent to what? 0.02 mole of aluminum. So let me erase this so that we can now calculate the volume. So using the formula M is equal to C times V over 1000. So N is the number of mole of the hydrochloric acid. C is the concentration of the hydrochloric acid. V is the volume that we're asked to calculate. So therefore, we now have 0.06 is equal to the concentration of hydrochloric acid, which is 2.00 times what? The volume over what? 1000. So you cross multiply. 2.00 times V is what? 2V is equal to 0.06 multiplied by what? 1000. So to calculate the volume, so divide both sides by 2, divide both sides by 2. When you cancel out, volume now be equal to, using my calculator, 0.06 times 1000 divided by 2. So the volume is what? 30 watts, cm what? Cm cube. So you can see it's as simple as ABC. So the answer is what? C. So it's as simple as ABC. The most important thing is for you to understand the question, write down the equation, and balance the equation. Make sure that the equation is balanced. Once these are done, you're on your way to the right answer. So it's as simple as what? A, B, C. So we're going to look at another example. We'll take another example. Okay, this is an example. Standardizing hydrochloric acid. Sodium carbonate anhydrous is used as a primary standard volumetric analysis. A solution of sodium carbonate of concentration 0.1 mole per dm cube is used to standardize a solution of hydrochloric acid. 25 cm cube of the standard solution of sodium carbonate required 35.0 cm cube of the acid for neutralization. Calculate the concentration of the acid. So the first thing for you to do is to write down the equation. You have to know how to write down the equation. So let's write down the equation. So it's between what? Sodium carbonate and what? Hydrochloric acid. So to investigate the standard solution of sodium carbonate, which is Na2CO3, reacts with hydrochloric acid. So you are going to form sodium carbonate aqueous, react with aqueous hydrochloric acid. So you have sodium chloride aqueous plus water, liquid plus what? Carbon dioxide gas. So the next thing to do is to make sure that the equation is balanced. So let's balance the equation. Sodium is 2 here, so we'll put 2 here. Sodium is balanced. Chlorine is 2 here, so chlorine is 1 here, so we'll put 2 here. Chlorine is balanced. Hydrogen is 2, hydrogen is 2. Oxygen is 3, oxygen is 1 plus 2, 3. Carbon is 1, carbon is 1. So the equation is balanced. So the next thing to do is to figure out the values you are given. You are given the concentration of sodium carbonate, which is what? Which is concentration of the base, which is 0.100. You are given the volume of sodium carbonate, which is equal to 25 cm cube. You are given the volume of the acid, which is what? 35 cm cube. So you are asked to calculate the concentration of the acid. So from the values we are given, the first thing we need to do is to calculate the what? Concentration. Is to calculate what? The number of moles of the base. So number of mole is equal to what? Concentration times volume over what? 1000. So concentration of the base, which is the concentration of sodium carbonate, which is 0.100 times the volume, which is 25 over what? 1000. So it's as simple as ABC. So let me just use my calculator. 0.100 times 25 divided by 1000. So you have 0.00 what? 25 what? Moles of what? Sodium carbonate. Of sodium carbonate. Now we go back to the equation. From the equation, 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid. Therefore, 0.0025 moles of sodium carbonate react with what? So 1 mole of sodium carbonate reacts with what? 2 moles of hydrochloric acid. Therefore, 0.0025 moles of sodium carbonate react with what moles of what? Hydrochloric acid. So we have to cross multiply. So what we'll have here, we'll cross multiply. So it will now be 0.0025 times 2 over 1. So x will be equal to 0.0025 times 2. So you have what? 0.005 moles of what? Of the hydrochloric acid, which is HCl. Now, we have to calculate the concentration. So remember, number of moles is equal to what? Concentration times volume over what? 1000. So the number of moles is 0. What? 005. Is equal to the concentration, that's what we're looking for, multiplied by the volume of the acid, which is 35, over what? Let me erase this so I'll have enough space. Divided by 1000. So you cross multiply. So 35C is equal to 0.1005 times what? 1000. So C divide both side by 35. Divide both side by what? 35. Cancel out. So the concentration now will be equal to 0.005 times 1000 divided by 35. So it will now be 0. What? 14 what? 143 moles per what? dm what? dm cube. So you can see it's as simple as what? ABC. The most important thing is just for you to write the equation, then make sure that the equation is balanced, and make sure you understand the questions very, very well. Very, very well. So you can see it's as simple as what? ABC. So please attempt as many questions as possible, practice many questions as possible, and feel free to contact me if you encounter any difficulty. Just reach out to me. I'll always be there for you. I'm Mr. Joseph, your chemistry teacher. Please don't forget to subscribe to my YouTube channel. Go to the comment section and give your feedback. Please reach out to me in case you encounter any difficulty. Solve as many questions as possible. Once more, I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you for listening.